to sort its distance to target color. So the problem is that we are giving a colors array. So the numbers is just means different colors. So for example, we have the colors array and we have color 1, 2, or 3. And we are also giving a queries array. So for each of the query, it has two values. The first one going to be the index I, and the second value going to be the color. So for example, for the first query, actually it means so the nearest color 3 from index 1. So this first one is the index, so this is going to be the index. And then we want to find the nearest color. So the nearest color 3, so the distance is going to be 3, and our final answer is going to be 3. And secondly, so we're going to check the nearest color to 2 at index 2, so it's going to be itself, so the distance is going to be 0. And for the third one, so the nearest index 6, so this is 2, 3, 4, 5, 6, and we want to find the color 1. So what is the nearest sorted distance to this index 6 with the color 1? So it's going to be 3 as well. So this is going to be the final answer. So if we are going to calculate this kind of colors array, it is difficult. But if we turn this colors array into a list, so we're going to put all the colors array. So for example, we're going to put all the colors array. So for example, this is color 1, and we're going to put the index as an array. So for color 1, we have like 0 or 1. This is 3, and we're going to put the index inside. And now, so this is for the color 1, and similarly for other colors. Now what we are going to do, and we are going to check this color 1 at index 6. So this is color 1, so we have this color array at index 6 is going to be here. So for example, this is the index 6, and what is going to be the distance? So inside the colors array, colors 1 array, this is the index. So we can use the boundary search to find what is the closest distance, and it should not be so difficult. So for example, this is index 6, while we are using the bisect left, so the 6 will go. So the index is going to be equal to, so for example, the length of the array is 3, so the index is going to be 3. It will go out of the range, so it means the distance is going to be 6 minus 3, so it's going to be 3. So we are going to return a 3. So in this way, this is only the log n time, and the final complexity is going to be n log n. So the maximum of the array is going to be n. So for each time of the query, it's going to be log n time. So the time complexity is going to be going to be n log n. I think it depended on the length of the queries, or k log n. So let's just check the length of the queries. So the length of the query is going to be length of the colors. So this is why the time complexity is going to be n log n if we are using the boundary search to solve the problem. Now let's start to prepare this kind of a solution. So let me prepare default dict, and inside it's going to be list, and I'm going to check all the colors. So the BC, I'm going to append the index I, so I'm going to enumerate the colors. So for IC in enumerate the colors array, and now I have this kind of a dictionary. Let me just print it out, and you can see what it looks like. Now let's start to check this kind of dictionary. So this is exactly what we need. So for each of the color, we're going to get an array, and we are not sure if we are having 3 colors or not, but we are giving 3 colors, it is okay. Even though we are giving 4 colors or 5 colors, it is okay. But we are having this kind of a dictionary. Now for each of the query, definitely we are just checking an array, and each of the array, because we are put the index inside according to the sequence, so every array gonna be sorted in increasing order. As we can see, this is 0, 1, 3, 2, 5, 6, or 4, 7, 8. So each of the array gonna be in increasing order. That is why we're gonna use the boundary search directly for the problem. Now we can check the queries. So for I, it is the index, and for the color I and C, inside the queries, we're gonna use the boundary search to solve the problem. So first of all, let's just check the index J. It's going to be the bisect left. So inside it's going to be an array, so it's going to be DC, which is the array, it's going to be the color array, and then we're going to check the closest distance to the current index. Yeah, so it's going to be this I. So what is the closest distance to this I? First of all, we're going to find this index j. Yeah, now we're going to return something, but before that, let's just check the length of the DC. If it is empty, I mean, if the colors array is empty, so that definitely there's no distance, so we're going to return a -1. So if there's no solution, so we're going to return a -1. So the result array going to append a -1. So let me just prepare a result array. So it's going to be an empty array. So this is the first condition. So if the length of the so if the length of the color array is 0, so yeah, if it is 0, so basically it means there's nothing inside. So we just need to append a not possible distance, so it's going to be a -1. Now we are going to check the range of the j. So if this j index is less than the length of the color array, so basically this means, for example, this is the index like 1, 3, 1, 3, but this is inside the colors array, and this I, for example, it is equal to 2. So what's going to be the minimum distance? So it's going to be like absolute of 2 minus 1 and absolute of 3 minus 2. So this is going to be the final solution. Yeah, so we are just running this kind of solution. So the result is going to append the minimum of the position, which is I, minus the color. So the color is going to be so the color going to be dj, because j is the position. Yeah, let me just think about it. So first of all, I want to get the colors array. So the colors array gonna be so j is the position of the so let me just think about it. First of all, I need to get the colors array, so it's going to be DC, and then inside I need to find the position. It's going to be z minus 1. I think we just need to think about it. That DC is going to be our current array, and we're going to use this value 2 minus a value before it, because currently this 2 will be at index 0, because 2 is, why we are using the bisect left, because 2 is more than and equal to 1. So basically the position for the 2 is going to be 1. So this is the index 0, so the index 2 for this position, while we are using bisect left to search this 2, so it's going to be a position 1. Yeah, so that means this position got a minus DC j minus 1. So this is going to be the first value, and and the second value gonna be I minus DC with j, but for each of them we're gonna use absolute. So let me just use an absolute. So we need to check the absolute value of the distance and absolute value of the distance I minus DC j. Yeah, so this is going to be the first condition, and the second condition is that j going to be equal to length of DC. Basically, it means it will go out of the range. So, for example, this. Yeah, so I'm not sure if it is recorded, but I just needed to fix a little bit about the problem, because this is going to be the first condition, if the length of the array is equal to 0, and another condition is if this j is less than the length of the array. Otherwise, we just if it is equal, we just get the final result. Let me just submit it to check if it works. Yeah, as you can see, it works. Thank you for watching. See you next time.